Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. In the lecture series of Material Studio, we are at the lecture number 36. And in the previous lecture, we just discussed about the triode TiO2. We just built the structure and we discuss about some parameters. So today's I will show you practically these steps, how these steps work, and how the calculation are. So this was the triode structure. You see. I think the dopant atom is changed, but this is the triode of TiO2. Okay, and I start this calculation. I think it has been 10 hours. I start this calculation. Maybe it take more to 2 to 4 hours. So you see, this is the convergence graph. Here we found the energy changes, electron volt per atom, maximum displacement, maximum force electron volt, and then maximum stress. So we see we have a blue line for the energy changes, and the other represents maximum displacement, maximum force, maximum stress respectively. But we found we have 2-3 lines which are consistent. We did not notice any changes since these are the maximum force and maximum displacement, maximum stress, because we are doing this calculation with zero stress, and that's why some lines are not changing with time along with optimization steps. So here is the convergence. Here is the energy graph. Okay, so we see it's start from 38, 39.5, and if we just look to this, okay, we have it. Okay, so what's the calculation steps? Okay, let's look at the status. We just start the geometric optimization with the 380 electron volt energy, and we use PBE function. So the number of iteration 37 iteration has been done, and it's give us energy, convergence, maximum displacement, force, and stress. So these are the calculation steps. As I start with the geometry optimization. So from the task section, I select geometry optimization. The quality, I start with fine quality, but later on I change some parameters, so that's why they show customized quality. And I run this calculation with the generalized gradient approximation along with PBE function. So okay, and then I did this calculation with non-polarized, as these are non-metal, so I uncheck this box. Okay, if we go toward the more option, we will find as I told you, I did this calculation with fine quality, and from the logarithm section I get BFGS algorithm, as we discussed about this in the previous video. So moving ahead toward the electronic properties, so you see I customize the cutoff energy up to 380 electron volt. The K point, the K point was not 1 × 1 × 1, it must be 2 × 2 × 2, but whenever we run the calculation, all the parameter has been disturbed, and then I use ultrasonic zero potential. From the more section, you see I customize the cutoff energy to 380 electron volt. To whom who think that how and from where I take these calculation step, they can follow the previous lecture, lecture number 35. So for better understand. Okay, and then moving ahead towards the properties section. From here I just select the population analysis, as I'm doing just geometric optimization. But for example, if one can do the calculation, property calculation with geometry optimization, but keep in mind about your computational resources, right? Regarding the job control section, is I apply the 6 cores because I'm using this PC for some other purpose, for some other job. So sometimes I use Google, sometimes I use other. So that's why I use 6 cores in parallel. Okay. So based on these calculation steps, I got these results. So maybe it takes about 2-3 more hours to the system to be reached to the ground state. So I will share the results accordingly. With this, thank you very much. If anyone have any question, please feel free to comment.